Hello, welcome to this lesson. In this lesson, we will talk about the numerical integration. The numerical integration is just another way of finding, or another method of finding area under a given curve. Okay, so under the numerical integration, we will discuss the trapezoidal rule in this lesson. Okay, then the subsequent lessons we will talk about the other two numerical integrations, which is Simpson's 1/3 rule, and Simpson's 3/8 rule. Okay, so in this lesson we will only discuss the trapezoidal rule with examples. Okay, so trapezoidal rule is just a method of numerical integration that's what used to find the area under a given curve. Okay, and it is actually used to solve find area of any first order polynomial. Okay, so first order polynomial that is of the form a0 plus a1b. Okay, this is first order polynomial. So so this is first order polynomial. So we have 2 points, that's a0 and a1. Okay, so for a single segment is when you have 2 points, we obtain a single segment, that's a0, then also have up to a1. So we have a single segment. So for trapezoidal rule, you can choose any number of segments. Okay, you can choose any number of segments that you want. Okay, so let's move on with the formula for finding area under a given curve using a trapezoidal rule. So this is the formula for finding area under a given curve using a trapezoidal rule. Okay, but let's try to prove this formula. So first of all, let's draw any function. Okay, so we have this x, y, such that y is equal to f of x. Okay, so let's try to find the area under this given curve. So this is f of x. Okay, so we have, so this is the area under this curve. Okay, so this is, we have x0, have x1, have x2 up to x3 up to xn. Okay, then we have the corresponding y value. So okay, so we have so this is y0, right? This is y1, sorry, this is let me draw it again. So we have this. Okay, so this x0, so this is what y0. Okay, this x1, so this y1. Okay, so x2, so this y2, x3, so this y3. Okay, up to yn. Now for the trapezoidal rule, we can join these lines. Okay, can join these lines, then we find the area of each of the shape plane figure under the what? Trapezium. Okay, under the curve, So we have this. So first of all, we find the area of this first shape, first figure another area, then another area. Okay, then we find the sum. That will be the total area under the given curve. Okay, so we know that, you see, we obtain, after joining all the points, we obtain a trapezium shape. So we have a trapezium here. Okay, we also have another trapezium there. Okay, we obtain trapezoidal shapes. Okay, and we know from geometry that area of a trapezium is half times the height, then multiplied by the sum of parallel sides. Okay, that's the area of what? Trapezium. So from this figure, we can say that the area is half times the height. Okay, so the height is unknown, so let's it be the height. Okay, so first of all, let's find the area of the first trapezium. So realize that y1 is parallel to what? Y0. Okay, so that will be y0 plus y1 plus the area of the second trapezium, half times the height. Okay, so y2 and y1 are what? Parallel to each other, so we have y1 plus y2 plus half times the height. Y3 and y2 are parallel to each other, so we have y2 plus y3 up to half times the height of yn minus 1 plus y of n. Okay, so from here you realize that each term contains half times the height, so we can factorize half times the height out. Okay, so this is the same as h over 2. Then why not? We stated that our y is just like what? F of x. It means that yn is the same as f of xn. Okay, and this means that our y0 is f of what? x0. Okay, so we have f of x0 plus f of x1. Okay, then when it comes to the second term, there is another y1 here, which is f of x1 plus f of x2. The next term, we have another y2 here, f of x2 plus f of x3 up to f of xn minus 1, f of x minus 1 plus f of xn. Okay, so that's the total area under this curve. Now let's simplify this. So we have h on 2, so f of x0, but we have f of x1 plus another f of x1, so that will be 2 times f of x1. We have f of x2 plus another f of x2, so that will be 2 times f of x2. Okay, so this means that all the middle terms are multiplying by what? By 2. Okay, so that will be up to 2 times f of xn minus 1 plus the last term, that is f of xn. Okay, now let's simplify this further. Okay, so therefore the area is given by h on 2 f of x0 plus, you see the middle term, we can just factorize 2 out, so 2 times f of x1 plus f of x2 plus up to f of xn minus 1, then we close bracket plus f of xn. Okay, so this is the formula for finding the area under a given curve using the trapezoidal rule. Now let's look at some basic examples. Let's solve some questions. So we have the area here. Okay, that's the area. H is the width, n is the segment. That's for single segment we have one number of segments, but for multiple segments we use this formula. Okay, for multiple segments in a given question, it depends on the question, and whenever you are given any question, the number of segments will be given to you, and that's what you are going to use to solve the problem. And the more you increase the number of segments, the more your answer becomes accurate. Okay, so now let's look at some basic examples. Okay, so we have two questions. Okay, so we are to use the trapezoidal rule to approximate the following integrals. We are to use the trapezoidal rule to approximate the following integrals. So we have the first one to be the so when we are let's solve the first question. Okay, so we are given n to be 6, then we have this integral. So first of all we let our integrand, okay, be what? F of x, which is 1 over x squared plus 3. Okay, then per the trapezoidal rule we need to find what? H. Okay, that's the weight. So the h is given by b minus a divided by n, but from this question b is the what? Upper boundary, a is the lower boundary, so that will be 2 minus 0 divided by 6. 6 is given already in the question, so when you simplify this you get 1/3. This means that you are going to, for the x values, you are going to start from 3 or 0. Okay, you are going to start from 0, that's the lower boundary, then you'll be adding 3 out, 1 over 3 up until you get to 2. Okay, so first term it will be 0, the next time you add 0, you add 1/3 to 0, then you get 1/3, then the next time you add 1/3 to 1/3, you get 2/3. Okay, then the next time you add 1/3, you'll be adding 1/3 to it until you get to the what? You get to 2, which is the upper boundary. Okay, so since it's ranging from what? 0 up to 2, and the step size is what? 1 out of 3. Okay, the step size is just like the width. Okay, now let's find the corresponding f of x value. So first of all, when x is equal to 0, we substitute 0 into this. That will be 1 over 0 squared plus 3. You get what? 1 over 3. We approximate to 4 decimal places to get 0.3333. When x is equal to 1/3, then f of 1/3 will be 1 over 3 all squared plus 3. When you simplify, you get this. Okay, so this, in all of them, we just substitute the values of x into our integrand. We can now apply the trapezoidal rule. Okay, so the trapezium rule is given by h on 2. Okay, but we know that our h is what? Half 1/3. Okay, then times these 2, which is what? 1 over 6. That's what we have here. Okay, then the first term plus 2 times the middle term. So the middle terms are, so here are the middle terms. Okay, that's f of 1/3 to f of what? 5 over 3. Okay, so that will be the middle terms. Okay, that will be the middle terms. Let me close the bracket here. Let me close it here. Okay, so f of 1/3. So first term f of 0, the middle terms. Okay, you multiply the middle terms by 2 plus the last term. Okay, now let's substitute our values there. Okay, so so this is the first term. We had 0.3333. Okay, then 2 times the middle term, so 2 times f of 1/3 plus 2 times 0. That's f of 2/3, then f of 1, f of 4/3, then f of 5/3. Okay, plus the last term, and the last term, that's what, f of 2. Okay, so we have our last term here. Okay, so when we simplify this, we get this, and you can also simplify to get this, and therefore your answer will be 0.4941, and its area, so we measure it in square units. Now you can pause the video and try your hand on this question. You can try your hand on the second question. Okay, so that's the integral from 1 up to 5 of x to the power 4 plus 2x squared minus 5 dx, and n is given as what? 4. Okay, okay, so we let, just like the first one, we let our integrand be f of x, then we calculate the step size, that's the upper boundary or upper limit, which is 5, minus the lower limit, all divided by n. So when you do that, you get 1. Okay, so this means that for s values, we'll start from 1, then we'll be what? Adding 1 to it until we get 5. Okay, so 1 plus 1 gives us 2, 2 plus 1 gives us 3, 3 plus 1 gives us 4, then 4 plus 1 gives us 5. Now we find the corresponding values of f of x. Okay, so the corresponding values of f of x, yeah. So when x is equal to 1, that will be 1 to the power 4 plus 2 times 1 squared minus 5, and this is 1 plus 2 minus 5, which is minus 2. The same thing applies to 2 and the other values of x. Okay, so when you solve it, you obtain these values. Now, using the trapezoidal rule, we have, that's h over 2, but we know our h to be what? 1, so 1 over 2. Okay, then you multiply by the first term is what? Negative 2, then the last term is 670, then 2 times the middle terms. Okay, so when we the middle terms are this, here are the middle terms. Okay, so we have 19, 94, and 283. So you multiply them by 2 and you simplify. When you simplify this, you will get 430 square units. Thank you.